Hello everyone. Today we'll be going over multiplying and dividing rational expressions. Okay, so from there we're going to start on our multiplying. So our multiplying rational expressions. Okay, so to do that, we have to review how to multiply basic fractions, really. So if you remember, just multiplying basic fractions, so if you have P over Q times R over S, that's just going to equal, you're going to multiply your numerator all the way across, so it's just P times R, over, then you just multiply your denominator across, so you have Q times S. Okay, so it's pretty straightforward for multiplying rational expressions also. So let's say, for example, if you have 7 over 5 times 2 over 3. Okay, so you just multiply the numerator across, so that's just 7 times 2 over 5 times 3. Okay, you're just multiplying your numerators, then you're multiplying your denominators. Okay, so nothing cancels out here, so we can just go ahead and make it 7 times 2, which is 14, over 5 times 3, which is 15. Alright, so it's the same way if we have a problem, let's say, for example, 5 over 8 times 8 over 9. That is just 5 times 8 over 8 times 9. Difference is you have two values in the factor up top and the denominator factor that can cancel out. So these two cancel out because 8 divided by 8 is just 1. So that gives us 5 over 9. Okay, now this is the step we have to remember when we're factoring our rational expressions. It's the canceling out part. Alright, so let's start with a few other examples. Okay, so let's say, for example, we wanted to multiply 25x over 2 times 1 over y to the third power. Okay, we'll throw a couple of variables in there. Alright, so for this one, just going to go ahead and rewrite it. So 25x over 2 times 1 over y to the third power. Move that up a little bit. That's just 25x times 1. Now you don't really have to put the 1 there because anything times 1 is just itself, but we'll put it there anyway. Over 2 times y to the third. Okay, so you can see here nothing cancels out in the numerator and denominator. So that just becomes 25x times 1 over 2 times y to the third is just 2y to the third power. Okay, so just like this example here, nothing canceled out in either one. Okay, so what would it look like if we did have factors that canceled out? Alright, so let's say, for example, we wanted to multiply x squared plus x over 3x times 6 over 5x plus 5. Okay, so this one, the first thing you'd want to do is factor, because you can't factor anything out or cancel anything out if it's in this form. Okay, so we have our x squared plus x over 3x times 6 over 5x plus 5. Okay, so if we go ahead and factor our x squared plus x, we can actually factor an x out of both of those. So if we factor out an x, that leaves us with x plus 1. And if we distribute, you see we end up right back there. Over 3x is just 3 times x, so it's nothing really more we can do with that one. 6, you can just actually make 6 equals 2 times 3. Okay, and the reason I did that is because we now see we'll have a 3 here that we can cancel out, so we're going to make that 2 times 3 instead of 6. Over here we can factor a 5 out of each term, so we have 5 and x plus 1. Alright, so if we just combine all of those, you will see we will have x times x plus 1 times 2 times 3, because all we did was just multiply everything up top, over 3 times x times 5 times x plus 1. Okay, so now we can start canceling out, because you see this x cancels out with this x. This 3 cancels out with this 3. It's just replaced with 1s. And this x plus 1 cancels out with this x plus 1. Okay. So the only thing left up top that didn't cancel out is the 2. And the only thing in the denominator that didn't cancel out is the 5. Okay, so that's your final answer for that. Okay, so let's go over our actual steps for multiplying our rational numbers. Okay, remember, if you're still writing, feel free to pause it and finish up. Alright, so we're going to go with our steps for multiplying rational numbers. Steps for multiplying rational numbers. Okay, now if you notice before, our first step was to factor all numerators and denominators. So factor all numerators and denominators. Okay, so just like we did before our second step, you want to multiply your numerator times numerator. Multiply numerator times numerator. And denominator times denominator. Okay, so now your third step will be to do just like we did at the end. You want to simplify by either combining like factors or canceling out common factors. Like factors or cancel out common factors. Okay, and all that means is that if you're left with a 2 and a 3 somewhere that didn't cancel out, you just go ahead and multiply them by combining them. Alright, so let's go ahead and start on our first example. If you're still writing, feel free to press pause. Alright, so let's say, for example, if we want to multiply 3x plus 3 over 5x squared minus 5x times 2x squared plus x minus 3 over 4x squared minus 9. Okay, so I'm just going to rewrite that. 3x plus 3 over 5x squared minus 5x times 2x squared plus x minus 3 over 4x squared minus 9. And we're going to factor each one right over here. Okay, so 3x plus 3. That one's pretty straightforward, because we can just factor a 3 out of both of those. Okay, so we have 3 times x plus 1. Okay, so we're done with that one. Okay, same thing with 5x squared minus 5x. We can factor a 5x out of both of those. So we factor out a 5x, and we're left with x minus 1. So that one's pretty straightforward. Okay, so we have our 2x squared plus x minus 3. Which we're going to factor using the a times c method. Okay, so here we know that a is equal to 2, b is equal to 1, and c is equal to negative 3. Okay, so we know that a times c is 2 times negative 3, which is negative 6. So that means we have to find two numbers that multiply to equal negative 6 and add to equal our b value, which is 1. Okay, so in this case, 3 and negative 2 works. So 3 times negative 2 is negative 6, and 3 plus negative 2 is positive 1. Okay, so that means we have to replace our middle term. So we replace x with 3x minus 2x. Oh, give me a little more room there. 3x minus 2x. 3x minus 2x. Okay, so just those two terms. So that means 2x squared plus x minus 3 will now become 2x squared plus 3x minus 2x minus 3. And remember, the last step is to factor by grouping. So we go ahead and make those to two smaller subsets. Okay, so from these two terms, we can factor out an x, which will leave us with 2x plus 3. And in these two terms, we can factor out a negative 1, which would leave us with 2x plus 3. Okay, so we have our common binomials. So once we get our common binomials, we can go ahead and factor that out. So we have 2x plus 3, and go ahead and draw a line through those. And what's left goes into our other binomial, which is x minus 1. Okay, so we factored our 2x squared plus x minus 3. And our 4x squared minus 9, we notice that's a difference of squares, because we can rewrite 4x squared as 2x squared and our 9 as 3 squared. Alright, so that gives us our A and B, because if you look at it, our A is equal to 2x, and our B is equal to 3. So our A plus B, A minus B, gives us 2x plus 3 times 2x minus 3. Okay, so that's all of our factoring. So, if we rewrite our 3x plus 3, that's just 3 times x plus 1. Our 5x squared minus 5x, that's just 5x times x plus 1. Oh, x minus 1, sorry about that. Times our 2x squared plus x minus 3. We know that's 2x plus 3 times x minus 1. Over our 4x squared minus 9, we know that's a difference of squares, and we have 2x plus 3, 2x minus 3. Alright, so now we see that all you have to do, you can either cancel it from here or you can put them all together. And you make it 3 times x plus 1 times 2x plus 3 times x minus 1 all over 5x times x minus 1 times 2x plus 3 times 2x minus 3. Alright, so once you do that, now you start canceling out. This 2x plus 3 cancels with this 2x plus 3. Okay, this x minus 1 cancels with this x minus 1. Okay, so as you see, we don't have anything else in the top and bottom that cancels out. So everything that doesn't cancel out becomes our answer. So you have 3 times x plus 1 over 5x times 2x minus 3. And that will be your simplified answer. Okay, so the hardest part will be the factoring for sum. But once you get past the factoring part of it, it's pretty much just a matter of canceling out. Alright, so hopefully that made sense. So we're going to try another example. If you're still writing, feel free to press pause. Alright, move this down a little bit. Okay. Alright, so let's say, for example, we wanted to multiply 8x squared minus 8x over x squared plus x minus 56 times 3x squared minus 22x plus 7 over x minus x squared. Alright, so we know that the first thing you want to do is factor all of those numerators and denominators. So I'm just going to go ahead and rewrite it, which you don't have to do, but I like to do it. 8x squared minus 8x over x squared plus x minus 56 times 3x squared minus 22x plus 7 over x minus x squared. And I'm going to factor each one of those on the side. Okay, so you have our 8x squared minus 8x. You can actually factor an 8x out of both of those terms. So if you factor out the 8x, that leaves you with x minus 1 inside the parentheses. And you can always do distributive property to double check. So we're done with that one. Okay, so you have x squared plus x minus 56. You don't have anything in front of the x squared value, so you just go right to finding two numbers that multiply to equal your c, which is negative 56, and two numbers that add to equal your b, which is 1. Okay, so in this case, 8 times negative 7 works for this, because 8 times negative 7 is negative 56, and 8 plus negative 7 is positive 1. So that means this will factor to become x plus 8 times x minus 7. Okay, so we have that one out the way. Okay, so usually in your factoring, the ones that require the a times c method will be your really time-consuming portion of the problem. So that's where this one comes in. That's our a times c method. So if we have 3x squared minus 22x plus 7, and we're going to use the a times c method. We have to know that our a is equal to 3, b is equal to negative 22, and our c is equal to 7. Okay, so for our a times c method, first thing we have to do is find our a times c. A times c equals 3 times 7, which is 21. Okay, once we found our a times c, we have to find two numbers that multiply to equal our a times c, which is 21. And those same two numbers add to equal our b, which is negative 22. Okay, and if you remember the trick that I told you last time, when we went over the a times c method in the previous video, when you have the absolute value of those two terms are just one digit off, because the absolute value of 21 is 21, absolute value of negative 22 is 22. The absolute value is just one digit off. It's usually just a combination of this value times 1 in some way, shape, or form. So actually it's negative 21 times negative 1 and negative 21 plus negative 1. Okay, so though if you remember that little hint, it will help you out every once in a while. Okay, so now we know we have to replace this middle term with those two. So we replace negative 22x with negative 21x minus 1x, which is still just negative 22x. So that means this will now become 3x squared. I'll move this up a little bit. There we go. Uh-oh. 3x squared minus 21x minus 1x plus 7. Okay. Now we go to our factor by grouping. Okay. So it looks here like we can factor a 3x out of both of those. So if we factor out a 3x, that leaves us with x minus 7, and you can distribute to double check. If you distribute, you'll end up right back there. And for these two, we can factor out a negative 1. Remember, when that middle term is negative, be careful, because if you factor out a negative 1, it changes the sign. So if you factor a negative 1 out of both of those, it just becomes x minus 7. And again, you can distribute to double check. Okay, which means now you have your common binomial. Okay, so we can go ahead and factor that common binomial out. So we factor out the x minus 7, and you can go ahead and cross those out if you like. and whatever is left goes into the other binomial, so that will be 3x minus 1. Okay, so that's your factor for 3x squared minus 22x plus 7. Okay, so now we have x minus x squared. We factor an x out of both of those. You have x times 1 minus x. Alright, so we're actually going to come back to that. Okay, so we're going to actually put a little check next to this because we're going to come back to that. And I'll show you the reason why. So if we replace all of those with their factors, x squared minus 8x is just 8x times x minus 1. So you have 8x times x minus 1. X squared plus x minus 56. We know that's x plus 8 times x minus 7. Okay, so x plus 8 times x minus 7 times 3x squared minus 22x plus 7 is just x minus 7 times 3x minus 1. X minus 7 times 3x minus 1 over x minus x squared. We see that's x times 1 minus x. Okay, and in a second I'm going to show you why we put the check mark here, because we're going to come back to that. Okay, so if we put those all over one fraction, we have 8x times x minus 1, or you can put 8 times x if you want to. You don't have to. Times x minus 7 times 3x minus 1 all over x plus 8 times x minus 7 times x times 1 minus x. Okay, and now we start canceling out. This x minus 7 cancels out with this x minus 7. Okay, this x cancels out with this x. Okay, now be really, really careful, because if you notice, this x minus 1 and 1 minus x can't cancel out. Okay, you could do it if it was x plus 1 and 1 plus x, because that's the same thing. But x minus 1 and 1 minus x are not the same. Okay, so everything that didn't cancel out yet, I'm just going to go ahead and rewrite that. So we have the 8 and x minus 1 and the 3x minus 1 over x plus 8 and 1 minus x. Okay, now if you remember back when we went to our factoring video, you can actually switch up those terms by factoring out a negative 1. So we can see here that, I'm just going to put that as a note, that 1 minus x is the same as negative 1 times x minus 1. That part, you can actually flip that. Okay, so that's why I put the little check there, because we would have to come back there. You could have actually done it at the beginning if you wanted to. But you can do it at the beginning. We could have made that negative x times x minus 1 and just canceled it out up there. Or you can do it later. Okay, as long as you do it before you put in your final answer, you're okay. You don't have to do it at this step. You don't have to do it as long as you do it before you're done. Okay, so we're going to go ahead and replace that. Okay, so we have 8 times x minus 1 times 3x minus 1 over x plus 8 times negative 1 times x minus 1. Alright, so you can put x minus 1 times -1 if you want to. The -1 can go on either side, doesn't matter. I just put it there so I won't forget it after I'm done canceling. Alright, so now we can go ahead and cancel out the x minus 1. Okay, and you'll probably see the need for that little trick quite a few times. So you want to be sure that when you see two numbers that have the same terms but they're switched across a minus sign, you want to remember that step. Okay, so that leaves us with 8 times 3x minus 1 over x plus 8 times -1. When you have that in times -1, you can just put the minus right up front, because that'll be just times over -1 is just the same there. So whenever you have it over that -1, just bring it out to the front. Okay, so that would actually be your final answer there. Alright, so now we're going to go into dividing rational expressions. Okay, and if you notice, I haven't had you do one of these problems. That's because when you're dividing rational expressions, you actually have to multiply anyway, because you're going to convert your division to multiplication. So that's where you're going to get your practice in. Okay, so as soon as we're going to have you do some division problems, it's automatically going to have you practicing your multiplication. So don't worry, you're going to have a couple of practice problems on your own. Alright, so if you're still writing, feel free to press pause, but we're going to go to our dividing rational expressions now. Okay, go ahead and leave that out the way and move this paper back down. Here we go. Okay, so dividing rational expressions. Okay, so now for dividing rational expressions, you have to remember your steps for dividing fractions in general. Okay, so your first step is you're going to write your first fraction. Okay, so your second step, you're going to change your division sign to multiplication. And then you're going to get the reciprocal of your second fraction, or you're just going to flip your second fraction. Let me clean that up a little bit. There we go. Flip your second fraction. Then your fourth step, you go through the steps for multiplying rational expressions. I mean, you go through your factoring and your canceling out and all that stuff. Go through steps for multiplying fractions. I mean, multiplying rational expressions. Okay, so even in the division problem, you're going to be dividing your rational expressions. I mean, multiplying your rational expressions. Alright, so let's go through a quick reminder on how to do the steps for dividing fractions. So we'll just start off with a basic fraction. So what if you have 5 over 3 divided by 7 over 5? Okay, so if we just rewrite it, your first step is you write down your first fraction, so that just stays 5 over 3. Your second step is your division changes to multiplication, so that becomes multiplication. Then your third step is you flip your second fraction, so 7 over 5 just becomes 5 over 7. And then you just multiply. Okay, so that just becomes 5 times 5 over 3 times 7, which is 25 over 21. Okay, so it's pretty much the same idea for rational expressions. Alright, so we're going to go ahead and do a couple of examples. So if you're still writing, feel free to press pause. Alright, let me move this down here a little bit. Okay, so let's say, for example, we want to divide x plus 2 squared over 10 divided by 2x plus 4 over 5. Alright, so remember the first thing you want to do is rewrite it. So if you have x squared, x plus 2 squared, sorry about that. X plus 2 squared over 10 divided by 2x plus 4 over 5. Remember your first step, write down your first fraction, so that stays x plus 2 squared over 10. Okay. Now remember your second step, your division changes to multiplication. And if you remember your third step, you flip your second fraction. So 2x plus 4 over 5 just becomes 5 over 2x plus 4. And then your fourth step, you solve it the same way you would your other multiplication of rational expression problems. Okay, which means we're going to go through each one and factor. Alright, so we're going to do those right on the side. So x plus 2 squared, that's just x plus 2 times x plus 2. Okay, so that one was pretty straightforward. Okay, now 10, we can rewrite that as 5 times 2. And the reason I did that is because it's a 5 up here. So if it's a 5 up here and we make that 5 times 2, those 5s can cancel out. Okay, 5 is just 5. That's nothing we can do with that one. Okay, and our 2x plus 4, we can factor a 2 out of both of those. So we have 2 times x plus 2. Didn't need this extra length like I thought I would. There we go. Okay, so that means our x plus 2 squared becomes x plus 2 times x plus 2. Our 10, remember we made that 5 times 2 for a very good reason, times 5 just stays 5, nothing we can really do with that. And our 2x plus 4 becomes 2 times x plus 2. Okay, so you can start canceling here, or you can just bring it all together on one fraction, whichever one you're comfortable with. So you have x plus 2 times x plus 2 times 5 over 5 times 2 times 2, don't forget that little 2 there, times x plus 2. Okay, so we can see here, this x plus 2 and either one of those will cancel out. This 5 and this 5 cancels out. Okay, so there's nothing else to cancel out. Okay, so you have x plus 2, and you have 2 times 2 here. Remember, you can combine those, so that gives you 4. Okay, and in case you're wondering, this 2 and this 4 does not cancel out. So if you left that as 2 times 2, actually let me do that and show you exactly what I mean. 2 times 2. Okay, these two will not cancel out. You can only cancel out when it's all multiplication. Okay, this has x plus 2 times x plus 2 times 5. This one has 5 times 2 times 2 times x plus 2. When you have just x plus 2 up here, this is not multiplication. You can't cancel it out. Even if you made it 1 times x plus 2, it would have to have another x plus 2 down here to cancel out. So this 2 and those 2's do not cancel out. So please be aware of that mistake. So that leaves you with x plus 2 over 4. Okay, that's a very easy mistake to make if you're rushing. So you want to make sure you don't make that mistake. Alright, so let's go ahead and do another example. Oh, if you're still writing, feel free to press pause. Alright, bringing that down a little bit. There we go. So let's say, for example, if we want to divide, let's say n squared plus 14n plus 45 over 11n plus 33 divided by n squared plus 16n plus 55 over 9n plus 27. Okay, so what I want you to do is press pause and try to solve this one yourself. Alright, so assuming you've pressed pause, you've worked through this problem, and you're at your final answer, we're going to go ahead and solve it. Okay, so you have a division problem, so the first thing you want to do is rewrite it. Okay, so you have n squared plus 14n plus 45 over 11n plus 33, and I'm just going to rewrite the problem. 16n plus 55 over 9n plus 27. Remember the first step, you write your first fraction. So you have n squared plus 14n plus 45 over 11n plus 33. Your division changes to multiplication. That's your second step. Then your third step is you flip your second fraction. So that gives you 9n plus 27 over n squared plus 16n plus 55. Okay, so that's your third step, which brings you to your fourth step, which means we just go ahead and multiply. Okay, so remember, this is first, this is your second, and this is your third step, which brings us to our fourth step, which is just multiplying. So we're going to go ahead and factor each one of those. So we have n squared plus 14n plus 45. There's nothing in front of the n squared, so we have to find two numbers that multiply to equal our c, and those same two numbers add to equal our b. Okay, so in this case, 9 and 5 works, because 9 times 5 is 45, and 9 plus 5 is 14. So this becomes n plus 9 and n plus 5. Okay, so 11n plus 33 we can factor in 11 out of both of those, because 33 is just 11 times 3. Okay, so we have 11 and n plus 3. So if you do the distributive property, you end up right back there. Okay, so same thing with 9n plus 27. You can factor a 9 out of both of those, and we end up with n plus 3. Okay, so n squared plus 16n plus 55 we have to find two numbers that multiply to equal your c, which is 55. And those same two numbers add to equal your b, which is 16. Okay, so in this case, 11 and 5 works, because 11 times 5 is 55, and 11 plus 5 is 16. So that means this will factor into n plus 11 and n times n plus 5. Okay, so we have all of our factoring done. So all we have to do is replace all those numerators and denominators and start canceling. So n squared plus 14n plus 45 is n plus 9 times n plus 5. We have n plus 9 times n plus 5. Okay, so 11n plus 33 is just 11 times n plus 3 over 11 times n plus 3 times 9n plus 27. We know that's 9n plus 3. 9 times n plus 3. And 9 squared plus 16n plus 55 is n plus 11 times n plus 5. Okay, now if you want to, you can rewrite these all over the same fraction, or you can just cancel it just like this. Because remember, you just have to have your numerator and denominator with the same factor. So you have n plus 5 here and n plus 5 here. You have an n plus 5 down here that cancels, well, up here that cancels with an n plus 3, sorry. N plus 3 up here that cancels with an n plus 3 down there. Okay, so this 9 and 11 don't have anything that could cancel out anywhere. This n plus 9 doesn't cancel out with this n plus 11. So we're stuck with 9 times n plus 9 over 11 times n plus 1. Oh, n plus 11, sorry about that. Okay, and that would be your final simplified answer. All right, so hopefully that made sense. Okay, so we're going to go ahead to our final example on this one. Excuse me. And I wanted to give this example in case you ran across a problem similar to this. So, what if we are asked to simplify 8z over z plus 3 divided by 32z squared, sorry about that, 32z squared divided by z squared minus 9. Okay, so this is what they call a complex fraction. And I'm going to show you how to convert this to something a little more familiar. Okay, so what we have here, and I'm just going to rewrite that problem. You have 8z over z plus 3, and that's divided by 32z squared over z squared minus 9. So what you're going to do now is you're just going to rewrite this division problem as a more familiar division problem. So really, this is just 8z over z plus 3 divided by 32z squared over z squared minus 9. Okay, so if you run across a problem that looks like this, just rewrite it from this type of division problem to this division problem. So where this is your numerator, well, I'll use this. This is your numerator and this is your denominator. Okay, so now what I want you to do is press pause, and I want you to go ahead and solve this one. Alright, so assuming you have pressed pause and you have worked out the problem and you are all set, we're going to go through our steps. So first, you're going to write down the first fraction. So you have 8z over z plus 3. Then you have your second step where division changes to multiplication. And then you have your third step where you flip your second fraction. So you have z squared minus 9 over 32z squared. Alright, so now we're going to go ahead and do our factoring. And we'll go ahead and do that all on the side here. Okay, so 8z, that's just 8 times z. Not much we can do with that. And the reason I left it as 8 times z is I could have made it 4 times 2 times z if I wanted to, but this 32 is 8 times 4. So I'll be able to cancel out those two 8s. So sometimes you just gotta think ahead a little bit and give yourself a little less work. Because even if I made this 4 times 2 times z, I could have made this 8 times 4 and canceled out the 4. And I would still end up with the same answer that I'm going to end up at the end. Alright, so let's go with z plus 3. That's just z plus 3. Can't really do anything else with that one. Okay, so z squared minus 9. Remember, that's the difference of squares. So z squared minus 9. Remember, that's just z squared minus 3 squared, where your a is equal to z and your b is equal to 3. So that's just a plus b times a minus b. So that's z plus 3 times z minus 3. Okay. You got to recognize your difference of squares and difference of cubes and all of those. And 32z squared, we're going to change 32 to 8 times 4 because it cancels out with that 8. So 32z squared is 8 times 4. And z squared, I'm just going to make that z times z. So one of those z's can cancel out here. So times z times z. So we have our 32 and our z squared. Alright, so we're all set to start rewriting and canceling stuff out. Okay, so 8z, that's just 8 times z over our z plus 3. Let me clean up that z a little bit. Looks a little bit rushed. There we go. So I have z plus 3 times z squared minus 9. Remember, that's z plus 3 times z minus 3. Over 32z squared. Remember, that's 8 times 4 for our 32. So 8 times 4 times z times z. Okay, so again, you can rewrite it over all one fraction, or you can cancel out here, where this 8 cancels out with this 8. This z or that z, doesn't matter which z, cancels out with this z up here. And this z plus 3 cancels out with this z plus 3 down here. Okay, so the only thing that didn't cancel out in your numerator is your z minus 3 over the only thing that didn't cancel out in your denominator is the 4 times z. Or just make it 4z. Let's clean that up a little bit more. There we go. Okay, and that would be your final simplified answer. Okay, so hopefully that made sense, and I will see you on the next video.